Okay, this is module 8. The first problem is about the Center for Disease Control. They're trying to see if a virulent strain of flu has spread to nearby regions. Okay, so you're going to get a plot of the data. Okay, how many groups are there? In this case, there's a single group. The measures are independent. They are continuous because they're counting antibodies. There's a single measurement per subject. Is there a reason to believe that the sample mean will be normally distributed, yes or no? Let's see here. Let's see how many. They have 69 individuals in their sample. From the histogram, you'll notice the data are skewed, but because you have a high sample or high number of individuals in your sample, more than 60, it means that the sample mean will still be normally distributed. So the answer to that is yes. Do we know the population standard deviation sigma, yes or no? All we know is that the count for the antibodies in a healthy person is 86, so that's mu, but I don't see sigma anywhere here, so I'm going to write no. What is the value of the population mean under the null hypothesis? Again, that's given to you in the question. It's 86. Which research hypothesis is appropriate? If the flu hasn't spread to this nearby region, then the antibody count for these individuals should be the same as the population of healthy people, so it should be equal to 86. If the flu has spread to this region, it should be larger than that. So the correct research hypothesis is B. Enter the sample mean. To get the sample mean, simply divide the sum of all scores by the number of scores. So 10,739 divided by 69. Okay, and up to 4 decimal places, that's 155.6377. What is the sample standard deviation round to 6 decimal places? I'm just going to compute this using the formula for the standard deviation, which was first given to you, I believe, when we were discussing central tendency, so that may have been tutorial 2, but it's certainly in the lectures and probably covered and has been covered recently as well. So I'm going to compute it now. 1,000. Okay. Is the population standard deviation of the sample mean known, or does it have to be estimated? Again, because for us to know the standard deviation of the population mean, we would have to know the standard deviation of the population. Therefore, we have to estimate the standard deviation of the sample mean from the sample standard deviation. So I'm going to put in estimated. What is the estimate of the standard deviation of the sample mean? It's simply the standard deviation value that you've computed divided by the square root of n. So it's 33.673594 divided by the square root of 69. Okay, and you have to round off to 4 decimal places, so that gives me 4.0 4.538. Okay, what statistical test should you use? A Z-test, t-test, Mann-Whitney test, Wilcoxon test, sign test, and these are the only options. In this case, you have continuous data, and you know that the sample mean is normally distributed because the number of scores in your sample is high enough, and you have, you know what mu is, so you can't do a Z-test, but you can do a t-test in this single group design. So B is the correct answer. Enter the value of the test statistic, round to 2 decimal places. The test statistic is simply the sample mean, which in this case is 155.6377 minus mu, which is, if I'm not mistaken, what was it, 86, divided by 4.0538, which is the standard deviation of the sample mean, 4.0538. And I have to round this to 2 decimal places, so the value I get is 17.18. Okay. Alright, enter the test statistic value corresponding to the lower boundary of the acceptance region. This is a one-tailed test. I will reject the null for a sample mean that's significantly higher than the population mean, so the rejection region is in the upper tail. Therefore, the lower boundary of my acceptance region is minus infinity. Okay. Alright, enter the test statistic value corresponding to the upper boundary of the acceptance region. This is simply the critical value for t. It'll depend on the alpha we're told to use. It's 0.01, as you can see here. And degrees of freedom are 68 because we have 69 individuals in our sample. So I'm going to change this to 68. And the area such that 99% of the scores are in the shaded region. Okay, and that is my critical value. Rounded to 4 decimal places. Okay, do we accept or reject the null hypothesis? Clearly, the value I obtained is much higher than the required critical value, so I reject the null. Okay, so that's problem 1.